Hello, welcome. In this video, we'll be looking at arcs and chords. In our last video, we discussed arcs and central angles. Remember that arcs can be, or an arc could be minor when it is less than 180 and it's named with two letters like arc RS. And the major arcs are named with three letters like RTS. Now, when a line or segment is drawn from R to S, which touches the circle in 2 points, that's a chord. In this lesson, we'll be working with three theorems. The first one says, in the same circle or in congruent circles, congruent arcs have congruent chords and congruent chords have congruent arcs. For example, in this circle O, arc TU, if arc TU is congruent to arc RS, then segment TU will be congruent to segment RS. And if we draw radius from the center of the circle to each of the vertex, then these two triangles will be congruent because all the radii are equal. And we already said that the two arcs, the two chords, are equal, are congruent. The next theorem says that the diameter is perpendicular to a chord bisects the chord and its arc. So, and talking about diameter, we are talking about radius as well, because radius is part of a diameter. So if a diameter is perpendicular, again, it has to form a 90-degree angle with the chord before this happens. So if the diameter is perpendicular, or the radius is perpendicular to the chord, like the diameter CD is perpendicular to AD, then it bisects both the chord into equal halves and the arc also into equal halves. And if we draw radius from the center of the circle to each of the vertex, then these two angles are equal. The diameter is going to bisect the angle also, as well as the chord and the arc. So, and the two triangles are congruent. They are right triangle as well. All right, the other theorem says here, in the same triangle or in congruent, circles, chords equally distant from the center are congruent, and congruent chords are equally distant from the center. So if we have chord RT and chord UV, if you draw a segment from the middle to down to the chord and this perpendicular chord, this is part of the radius, getting to the end. If they are equal, then the two chords are equal, and of course the two arcs will be equal too. So in this case, x would be 4, and since UV is 6, RT would be 6 as well. So ST would be 3 because this bisects the chord. All right. So we're going to use these theorems to solve geometric problems. All right, here's the first one. So here's the circle, the diameter, and and we have a chord that is perpendicular to the diameter. Therefore, if this segment is 12, that is going to be 12 also. So this is a radius which is 13. That makes the this other radius is also 13. So if you use Pythagorean theorem and check it, so x is 12, y is going to be 12 also. So a right triangle is formed there. So and here is what I showed the work. Because this 13, we set it 13 squared equals 5 squared times x squared, and then we use it to solve x and get 12. Here's another one. Okay, this is a radius from the middle of the circle to the side, and here is chord AB. So here we have angle 60. So since we have angle 60 here, that means that this angle would be 30. Therefore, this is a special triangle. If that is a special triangle and the hypotenuse is 6, for special triangle, remember that the hypotenuse, again, the hypotenuse in a 30, 60, 90 triangle, the hypotenuse is is 2 times the small leg. So if the hypotenuse is 6, then the small leg is going to be 6 divided by 2, which is 3. So x would be, y, the small leg has to be opposite the small angle, so is y is 30. Y is 3, I'm sorry, y is 3. So y is 3. And what is x? X is opposite the larger angle, so it's going to be the longer leg. So what is the longer leg? The longer leg is the small leg times the square root of 3. So we already find the small leg, which is 3. So it's going to be 3 times square root of 3. So x is 3 times square root of 3. And then measure of angle AB. Okay, measure of angle AB is a minor chord. Chord AB. Chord AB is a minor chord because it is named with 2 letters only. So chord AB is there. So the measure of chord AB is going to be the same with the measure of the central angle. Okay, let's check if we draw a central, that all connect to here. Oops. Just assume this is a straight line down. So it is another radius. So the radius here is 6, just like the radius here. And since this angle is 60, this angle will also be 60 because this radius is going to bisect the chord. Therefore, you have 60 plus 60, that is 120. So this is going to be 120 degrees. Okay, let's look at another one. Here we have a chord and another chord here, and of course they show us that these 2 segments are equal. And when the chords distance chord, where the chords are equally distant from the center, then the chords are congruent. So this line, this symbol shows us that these 2 segment distance are equal. Therefore, these 2 chords are equal. And by the way, this bisects, is perpendicular to the chord, so it bisects the chord. So if this is 8, x must be 8 as well. So x is 8. And since this bisects the chord also, and these 2 chords are, this 2 chord is equal to this chord, so 8 plus 8 is 16. So y would be 16. Okay, that is how these the theorems, the three theorems we just looked at, that the diameter, if the diameter is perpendicular to the chord, then it bisects it, both the angle and the chord and the arc. And congruent chords make up congruent angles, congruent arcs, and we have equal distance from the center to the arc, then it means that the chords are equal also. So these three things kind of go together. If this is the equal distance from the center, means equal arc, equal chord, and equal arc as well. Okay, all right.